Assalamualaikum warahmatullahi wabarakatuh. Good morning. So today we'll be continuing the moments topic. So to start off with, let's look at the lesson objective for today. So today you'll just be learning about being able to describe and use the principle of moments. So this learning objective will involve the following steps to success. You need to be able to recall the formula for moment. So this one you already learned last lesson. Able to state the principle of moments. And then lastly, able to use the formula and principle of moments on a given example. So this time the lesson is more heavily focused on mathematical equations. So first, let's recall the formula for moment. So the formula for moment can be seen from this triangle. So M was equal to Fd, where M was your moment, F is your force, D is your perpendicular distance. So if you look here, your moment, the SI unit was in Newton meters. Distance from the pivot, and needs to be perpendicular, is in meters, and force is in Newton. Okay, so we learned that last lesson. Today's lesson is about the principle of moment. So principle of moment states that when a body is in equilibrium, the sum of the clockwise moment equals the sum of the anti-clockwise moment. So this sounds long, but you can just simplify it to basically anti-clockwise moment is equal to clockwise moment when balance is achieved. So here, balance and equilibrium is basically the same thing. So when a body is something is in equilibrium, when something is balanced, the sum of clockwise moments is equal to the sum of anti-clockwise moment. That is the principle of moment. So, but what does it actually mean, principle of moments? How does it actually make things balance? Okay, let's look at it again. Anti-clockwise moment is equal to clockwise moment. This is the most important one. Only when it is balanced. So the moment on the anti-clockwise direction should be equal to the clockwise direction. So the girl right now is having a moment on the anti-clockwise direction. The boy is producing a moment in the clockwise direction. So if we calculate, so let's look at the girl first. Okay, the moment for the girl, so moment was equal to force times distance. So force for the girl was 375 Newton. The distance is 2 meters. Okay, so 375 newtons times 2 meters gives you 750 Newton meter. That is the moment for the girl. Let's look at the moment for the boy. Again, moment is equal to force times distance. See, this formula is very important, so you need to remember it. So the force of the boy is 500 Newton. Then the distance from the boy to the pivot is 1.5 meter. So you multiply this, and you should also get 750 Newton meter. So from the girl's side, you have 750 Newton meter. From the boy's side, you also have 750 Newton meter. So their moment is equal. So that's why the seesaw is balanced at this point. Even though the boy is heavier than the girl, but the moment is the same. So the seesaw is balanced. Okay, let's look at another example. So this time, you have a seesaw again, balanced on a beam, and you have 3 different forces acting on it. So you have force 1, force 2, and force 3. Okay, so on this side, on your left side, This is your anti-clockwise moment. On your right side, you have your clockwise moment. Yes, because this one, F3 is going that way when you push down. F2 and F1 is going that way when you push down, because this is the pivot. Okay, remember that principle of moment today? Anti-clockwise moment is equal to clockwise moment. In this case, if you look at your anti-clockwise moment, you have two moments, F1 and F2. So this one you calculate one by one. So F1, the distance between F1 and the pivot is that much, which is 1 plus 1, 2 meters. So F1 times D1 for the first one, your F1 is 50 Newton times 2 meters plus F2 is also anti-clockwise, so you put that there. So your F2 is still 50 newtons times your D2, so your F2 is only this long to the pivot, which is just 1 meter. So that's just times 1 is equal to the clockwise moment. So if you look, the clockwise moment, the force, they don't tell you. So what you're looking right now is trying to look for the force. So the force here is M. Okay, M is not moment, M is force. And then F3, the distance from the force to the pivot is 1. So what we're looking for is M times 1 meter. Okay, so you just calculate the whole thing. So 50 times 2, that's 100 plus 50 is equal to M. Okay, M times 1 is just M. So M, the one that you want to find out, is 150 Newton. Newton, because you're looking for a force this time. So basically, what you just need to know for principle of moments is this. Anti-clockwise moment is equal to clockwise moment. And then you need to know which forces is the anti-clockwise, which force is the clockwise. And then you just put it into the formula. Okay, to make it simple, anytime you see principles of moments, you just think about anti-clockwise moment is always equal to clockwise moment, only when it's balanced. Okay, so you just make this into the formula. So this is your first one, first two, F1 times T1, that's your anti-clockwise moment, is equal to F2 times D2. And this is usually what you use when you see exam questions. And that's it for today. Thank you for listening.